Trigonometry is the branch of mathematics that deals with the relationship between sides and angles of triangles and all the calculations based on them. So it's very important that you remember SOH, CAR, TOA.
So let's start with SO. The S stands for sine, which is equal to O. O stands for the opposite side, and then it is divided by H, which stands for the hypotenuse side. In a right angle triangle, the opposite side is named because it is opposite to the angle, and the hypotenuse side is the side opposite to the right angle and always the longest one.
The next one is CAR. C stands for cosine. It is equal to the adjacent, A, divided by the hypotenuse, H. In a right angle triangle, side A is adjoining to the angle, and side H is the hypotenuse, as we already know, the longest. The last one is TOA. The T stands for tangent, which is equal to O, the opposite, divided by A, the adjacent. In a right angle triangle, the O side is opposite to the angle, and the A is adjoining to it. The first example will be finding a side. We're going to use this triangle for the example. It has an angle of 38 degrees. Its adjacent side is 8, and its opposite is x. This means it is tan. As we already know, the formula for tan is TOA, the opposite divided by the adjacent. So, tan 38, that is the angle, equals x, that is the opposite side, divided by 8, that is the adjacent side. We will use inverse operation to find x. So, tan 38 times 8 equals x. That would be 6.25. We will introduce example 2 by finding an angle. For the example, we're going to use this triangle. We need to know theta. We have the opposite side, which is 10, and the hypotenuse, which is 15. As we have both of these sides, we're going to use SOH, or sine. To find an angle, we need to use sine minus 1. So sine minus 1 equals 10, that is the opposite side, divided 15, that is the hypotenuse. Sine minus 1 equals 41.81 degrees. So theta equals 41.8 degrees rounded up to 3 significant figures. The first topic we're going to introduce is algebra. The basics of it is replacing numbers by letters. These are some examples. So how is algebra related to trigonometry? We can find this using this triangle. Some of the sides can be labeled with letters. As we know, the letters can also label numbers. One of the uses of algebra is finding missing sides. We can do this with these formulas. These are called the Pythagoras theorem. The second topic will be similar shapes. In geometry, two shapes are similar when the only difference is size. Both of these triangles are exactly the same shape. The only difference is the size. As we can see, the left-hand side triangle, the measurements are the double of the ones in the right-hand side. This means it has a ratio of 1 to 2. This is a perfect example of similar shapes. As we can see, similar shapes use trigonometry when they label the sides and sometimes the angles. In some of the cases, the similar shapes use trigonometry ratios to find the difference between each of them. Trigonometry is seen when these shapes are triangles, but there are also similar polygons and different shapes that are not related to trigonometry. On the left hand side we have the omega block. We're standing with a clinometer measuring the angle of elevation, which is 44 degrees. On the adjacent side we have 14.5 meters, which is the distance between us and the block. We need to find the opposite side, which is the height of it. So we're going to use tan. To calculate this, we're going to do tan 44 equals x, that is the opposite side, divided by 14.5, which is the adjacent side. This means that we need to calculate tan 44 times 14.5 to find x. After doing this calculation, x equals 14 meters. We need to add our height, that is 1 meter 75, to the 14 meters that we got to find the real height. This means the final height is 15.75 meters. This is the omega block. We measured its height with this tool, a clinometer. It's basically half a protractor with a straw on the top of it, where you can look through. It has a string with a weight on the end. As you tilt the clinometer, the string shows the angle of elevation. This is a diagram of the omega block. As you can see in the measurements, the highest floor is the first one, with a height of around 4 meters. The next 3 floors have a height of 3 meters 50 each one, plus the difference between each of the floors. If we add all the measurements of each floor's height, we would have a final height of 15.64 meters. If we compare the result we got for the omega block's height using a clinometer, which was 15.75 meters, to the real measurement, we only have a difference of 11 centimeters. This means that our results were fairly precise.
One of the things that most requires trigonometry is architecture. In architecture, trigonometry is used for many purposes like finding the sine of an angle will help you figuring out how much material is needed to construct. It is very helpful to make sizes and proportions as accurate as possible. It lets you know how much space you have for building and also what is the most efficient way of building something, increasing size and minimizing cost. Also, construction workers use trigonometry a lot to calculate the best way to build projects that are stable and safe. But these are just a few examples of the many ways that trigonometry is used in architecture. One specific example is that the use of trigonometry is essential to determine how long a bridge should be. A constructor can use angle properties to discover the length of what the bridge is going to cross, for example a river, and also the length of the bridge so it can reach that point and also resist. For example, if he's standing on the river's edge about 10 feet from where the bridge will start, all he needs then is to measure the angle from where he is standing to where the bridge will stop. Then to calculate the rest, he will only need to use the properties of a right angle triangle. Finally, another example is the use of trigonometry on determining roof structures. The angle of trusses, which provide support for holding up roofs, and the length of rafters in the roof are determined using trigonometry. For example, in a triangular shaped roof, if you already know the length of the rafters and the horizontal length of the roof, you can use the law of cosines to determine at what angle the trusses should be cut for maximum support.